Good morning, everyone. I welcome you all to this discussion session. And today we are going to look at our third property, which is of the indirect utility function, which is the strictly increasing in y. So what we're saying that anytime that your y here represents your income, right? So anytime that your income is increased, we expect your maximum utility to what also increase. There shouldn't be at any circumstance or any case where there is an increase in your income and it ends up what reducing your maximum utility. So that is what it means, strictly increasing in y. So let's now use our algebra to show this. Economics is basically about mathematics. So you always have to, if you don't like mathematics, then I would just advise you to start learning more of mathematics, because basically everything that we're going to do dwells on mathematics. So I'll start with writing mine. We said that V, with our indirect utility function, is equals to what? Your utility, which is replaced with all the optimal x and y, which is a function of p and y. Great. So strictly increasing y means the v, the y is always positive, greater than 0, because it is always increasing, right? So let's look at it from this expression now. The v, p of y, the y is equals to, now we have different commodities here, commodity x1, x2, up to xn, right? So we don't know the one that we are going to differentiate. We are just going to use one. So in that case, I'm going to use summation I equals to 1 up to n, right? Now this is a function of, I want to differentiate this respect to y, define the y. But because the y is a function of what? Another function, then I will first have to differentiate this utility respect to x. Then I differentiate the s with respect to what? Y. So that I'll have it as du dx multiplied by the x dy, right? Then this will cancel this. So this ends up cancel this. Then I have the u dy again, because I want to differentiate u respect to y. But because u is a function of another function, I first have to differentiate u respect to x. Then I differentiate x respect to what? Y. So yeah, so that is what I've done here. So let me clear this. Great. So let me come back again. Now, if you remember, in our first discussion, when we were looking for our Marshall demand function, we set up our Lagrangian and we differentiated our Lagrangian respect to what? Xi's. So that first order condition gave us something like, from that first order condition, we had, if you remember, we had marginal du, we had du the xi minus lambda pi equals to 0. From that first discussion that we did, we have something like that, which implies that du dxi is equals to what? Lambda pi. Lambda pi. So what it means is that in place of this expression, I can write lambda pi. Is okay? Then I'm going to write, if that's okay, then I'll write differentiate v py with respect to y is equals to summation of I equals to 1 up to n lambda pi dxi dy. Good. Now because the lambda here is constant, I can take it outside. That will give me lambda out, summation of I pi dxi dy. Great. Now we have this. You may also remember that when we have the budget constraint, so what it means is that when you sum up our prices multiplied by the commodities plus P2, X2 plus Pn, Xn should be equal to what? Our income. So what it means is that when we multiply the prices of each commodity by the respective quantity that we purchase, and we sum up, and it should be equal to what? Our income. Great. So I want to have this expression in what I have here. So because I'm looking at what happens to our x1, x2 when our income was changes, so I'm going to differentiate this expression with respect to income, right? So I'll have P1, the x1, the income, plus P2, the x2, the income, plus Pn, the xn, the income, right? Now, when I differentiate income respect to income, I have what? 1. So look, this expression can be also summarized as a summation of I equals to 1 up to n pi is okay. Then the xi dy equals to 1 is okay. So then what it means is that this expression here, look at this expression here, the same as 1, right? Then in place of this, I can write out 1. Then that means then we have our differentiate v with the function of py dy is now equals to what? Lambda into bracket 1, which is equals to what? Lambda, and is greater than what? 0. So this lambda is known as what? Marginal utility of income. Marginal utility of income. That is, if we increase our income by just say $1, we are able to increase what? Our total utility by what? Lambda. So the lambda here represents marginal utility of income. The additional utility that you derive, you add to your maximum utility by just increasing your income by just $1. It's okay. So thank you. And in my next section, I'm going to look at what happens when there's a change also in what prices. So we said this was okay. So great. So let's try with the previous one that we did. We solve for our marginal utility. So we solve for our indirect utility, and we had what v of py equals to y into brackets p1r plus p2r or into bracket -1 over r, right? Now when I differentiate the v dy, what am I going to have? The v dy, the y is only with this one, so it gives me 1. So it comes p1r plus p2r -1 over r, and which is what? Greater than 0. So this is the v dy, and it's greater than 0, as we said in the question, it's always increasing in what? Y. So thank you, and don't forget to subscribe to my channel.